Hello, in this video I will be showing you how to solve systems of three equations. Now to really excel in this topic, you must be comfortable with solving systems of two equations. If you're not, I would suggest that you go back and look at a separate video which is solving systems of two equations. So systems of three equations are pretty similar to solving systems of two equations, except that you have to compare two of the three equations. So throughout your solving of this problem, you will be comparing these equations. You could also compare these. So you're just comparing all the systems to each other, and through that you're going to be able to solve for each variable. So let's go. I'm going to go ahead and take a look at the first problem. So we've got x plus y plus 2z equals negative 8. Then our second equation is 3x plus 2y minus 2z is equal to negative 10. X minus y equals negative 8. Now for the sake of teaching, I'm going to number each of these equations. So you've got equation 1, equation 2, and then equation 3. Now, what you're going to do after this is you're going to take a look. Sometimes one of the equations could have two variables, such as equation number 3, and sometimes your equations will have three variables. It just depends on the problem. And we're going to be looking at one with one equation that has two variables rather than three. So let's take a look at this. So let's take a look at equation number 3 first, because that's our equation that has the least amount of variables. So x minus y equals negative 8. So let's go ahead and just isolate one variable. So let's take this over here. Let's just say x minus y equals negative 8. Go plus y, x equals 2. X is equal to y minus 8. So we've got one equation, and we've isolated the variable, which is x. Now what we need to do is we'll take this isolated variable, and then we'll take it, and then we'll plug it into these two separate equations. So we'll plug it into those two separate equations, and then you'll end up, once you've plugged it in, you'll take those two equations that you substituted into, and you'll get a system of two equations. From there you solve, and then you get one variable, and then you plug it in. So I'll just show you. So you've got x, right? So it'll be y minus 8, which is just our x value, plus y plus 2z equals negative 8. So let's go ahead and solve that. So y minus 8, that's just 2y plus 2z. We'll go plus 8 is equal to 0. So that's our first equation. This, I'll relabel, this is the product of our first equation. Now let's take a look at our second equation. So now we've got, I'm going to choose a different color, so we'll go right here. So now let's take a look. So 3 times x, so x is y minus 8, plus 2y minus 2z equals negative 10. Now once you've gotten here, just expand this. 3y minus 24 plus 2y minus 2z equals negative 10. Now just add like terms, so 5y minus 2z, and then you're going to add 24 to each side. That'll be equal to 14. Now I'm going to number this as the product of my second equation. So now we've got two equations. That each have two variables. So now what can we do with that? We'll reset this into a system of two equations. So we'll reset into a system of two equations. So you've got 2y plus 2z equals 0. And then 5y minus 2z equals 14. So those are our two equations. Let's go ahead and solve normally. So you've got, I'll just do elimination, because in this case it's really easy. It's already eliminated for us. So, positive 2z in the first equation and minus 2z in the second equation, they cancel each other out. So they cancel each other out. And I will just add the two equations together. So we've got 5y plus 2y equals 7y is equal to 14 plus 0 is 14. And now we'll be left with 7y equals 14 divided by 7. Now y equals 14 by 7, which is 2. So you've got y equals 2. Now that we've got one of our variables, all we have to do is plug in, once again, like two systems. We'll take this, plug it back in to, let's say, this second equation. It can be 1 or 2. I'll just take 2. It doesn't really matter. So now we'll take this, and now we'll be left with 5 times 2, which is our y value, minus 2z is equal to 14. 10 minus 2z is equal to 14. Subtract 10 from both sides. Minus 2z is equal to 4. Divide by negative 2. Z equals 4 divided by negative 2. That will be negative 2. So now we've got two of the variables. Now the only thing left is to plug it back into one of the equations. In this case, we can choose 1, 2, and 3 to plug it in, because x hasn't been solved. However, sometimes it's just better to plug it in to one of the equations with 3 variables, because it makes solving a little more easier and practical. So now we'll take this. So we've got z is equal to negative 2. Plug it back in, and y is equal to 2. Plug that back in. So let's take the first equation. Okay, let's take the first equation. So now we've got x plus y, which is 2, and then we'll take plus 2 times z, which is negative 2, is equal to negative 8. X plus 2 minus 4 equals negative 8. X minus 2 equals negative 8. Add 2 to both sides. X equals 8. Minus 8 plus 2 is minus 6. So your x value will be equal to minus 6. Let's go ahead and put this all into 1. So our final solution here is going to be x equals minus 6, y equals 2, and z equals negative 2. That is our final solution to this problem. Be sure to watch out for future videos. Please ask questions in the comments below. Thank you.